All right, everyone, welcome back. This is going to be the final project for Dr. Ozbay's class. It's going to be XFLR5. That's the program that we're running. And we are doing analysis on 3D wings. So let me just pull up the instructions real quick on my phone so that I can make sure that we got everything covered. So my name is Morgan Cosgrove. I'm going to be doing part A, which means that I am going to be showing you how to do the geometry and analysis for a rectangular wing with aspect ratio of 10. So first things first, you're going to go to Module, and you are going to go to Direct Foil Design. Go to Foil, NACA Foils. Now in the projects it tells us that we are going to be using NACA Airfoil 2415. Going to do 150 panels for accuracy. Alright. So you can go in here and do a batch analysis, which is going to help with the ANSYS part of this project. But since I only need to show you, I need to show you geometry and kind of the basics, we are going to do that through wing and plane design. Okay, so you're going to be brought here, and this is where we're actually going to be making our geometry. So we're not doing an elevator, we're not doing a fin. This is simply a wing design. I'm going to call this wing AR10 because we're doing aspect ratio of 10. Then we're going to go to define, and this is the important part. So this is going to be your half chord length, and if we want aspect ratio of 10, knowing that our chord length is 1 meter, because that's given to us, that means that our half chord length is going to be 5. So that would give us aspect ratio of 10, because this is the half chord length. So it goes 5 and 5, and this is the whole thing. This whole aspect ratio is going to be 10, which is exactly what we want. Right, so we do no offset, no twist, select our foil. Alright, this is where you're going to want to take a screenshot. Boom. Save it. Save. Alright, so now that we've done that, we are going to go ahead and define an analysis. In the project, it tells us that our free stream velocity is going to be 50 meters a second. Meters a second, analysis, LLT. Just 1 second. There we go. Okay. I was a little confused by the Reynolds. I know the Reynolds number is 3.3 million. So I was like, But obviously it's because I didn't change my free stream velocity yet. One more check. Then we got LLT. Okay, we're all good. This is lifting line theory. Okay, we got 2 of them now. Okay, so these are already put in place. You're going to want to click sequence, and the project tells us to go from -5 to 15, increments of 1. All right. Right, so I misspoke earlier. Actually, we have to go to this first, do exactly what I just did, and do 1 million Reynolds, and we are going to analyze this right here. Same settings, analyze. And do a batch actually. Gonna do the batch. Analyze. This is going to give us a bunch of points, which works for us. Okay, so now that we've got that, we can go to wing and plane design. There we go. This is what we're looking for. Okay, so I misspoke earlier. So you are going to want to first go to the direct analysis. You're going to want to do a batch analysis. That way you can get some points, and then you go to wing and plane design and do everything that I showed you before with all of these settings. And now you get the slopes that you want. So they ask for CD alpha, CL alpha, CL over CD alpha, and efficiency over alpha. Okay, that's exactly what we were looking for. Brilliant. Okay, so now that we are here, we're going to want to unclick all of these, and we're going to want to go to the angle that we're looking for. So here it says that at 5 degrees angle, so we want 5 degrees angle of attack specifically. So remember back here I showed you guys how to do the second part, which is plotting CL, angle of attack, CL over CD, blah, 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 blah. Now is the part where we do specifically, we want to know what happens specifically at 5-degree angle attack. So you just want to unselect it and then reselect it. You can make sure that all your stuff is correct by looking at the aspect ratio it gives you, and all your values. Make sure that everything's making sense. So at 5 degrees angle attack, we want variation of local lift coefficient. So this is super simple, guys. If you guys are having issues with the graphs, if they're giving you different variables than you need, you're just going to go here. And so we need local lift. There we go. Local lift coefficient. That's 1 versus Y span. There you go. Then you're just going to export it right there when you're ready and take it to Excel. The next thing is going to be induced angle of attack. Just like that. Go ahead and export it again. All right, and then induced drag coefficient. Voila. Go ahead, export it. You know the gist. All right, so that is essentially everything. Make sure your settings are all good. Make sure you click the sequence button, because it's not going to let you input anything else if you don't put sequence. It's a whole big thing. But anyways, yep, that is the tutorial. And I hope you guys liked it. Thanks. Bye.